Hola, good evening, Earth scientists. How are you doing? Welcome to our review for the midterm, which we're going to be taking next week. The way we're going to do this review is I will let you attempt the question yourself, and then I will do a review of it, and then I will let you reattempt the question, but in a different way, or a similar question. Okay. So question number one can be about solar system. I'll let you answer it. Then I will review it so that you know whether you got it right or wrong. And then question number two is going to be similar or still going to be on solar system. And then you answer it. And that's how we're going to proceed with the review. Also, to make this review very short, I'm only doing the review for the ESRT pages, some of the ESRT pages that we have worked with. Yeah, so take out your Earth Science reference table. You're gonna need it. You always need that. That is your power for Earth Science. So take it out. All right, and let's jump right into it. Also, I provided a PDF document of this with the Google Classroom post. So you want to go back to that Google Classroom post and open this PDF so that you have access to the questions themselves, and you are able to pick your right choices each time I ask you to answer any of the questions. So ensure you open it in another tab. Open the PDF question packet in another tab. All right, let's jump right into it. Question number one. I want you to read it. I'm going to zoom in. You can also look at it in the PDF and answer it. All right, let's see if you got your answer right. Question number one says, how do Jupiter's density, so that is the keyword there, and period of rotation, so the period of rotation of Jupiter and the density of Jupiter, how does it compare to Earth's? So I'm comparing these two things. Period of rotation simply means how long it takes to spin. How long to spin, all right? How long it takes for the planet to complete one spin. So that's what we are comparing. We are comparing those of Jupiter to that of Earth. And what Earth Science reference table can help us with this? This is definitely ESRT page number 15, solar system data. So turn with me to page 15, solar system data, and we are looking at the density and period of rotation. So which column here talks about density? It is this column right here, talks about density. And what column talks about period of rotation? Period of rotation at equator is also right here. So those are the two columns that I'm going to be working with, and the question definitely talked about Jupiter, so we're working with Jupiter here, and the period of rotation for Jupiter is 9 hours. How does that compare with Earth's? Earth is 23, so Jupiter spins faster than Earth. Do we agree? Yeah, because Jupiter just complete one spin in just 9 hours 50 minutes, approximately 10 hours, and Jupiter is done spinning, while Earth takes a whole 24 hours. Oh my God. Okay, and then the density of Jupiter is 1.3 and the density of Earth is 5.5. So in terms of density, Earth has more density. In terms of rotation, Earth takes a longer time to rotate. Earth has more density and takes a longer time to rotate. So let's look at our option for that question. Jupiter is less dense and has a long period of rotation. Jupiter is less dense, that is true, but Jupiter has a short period of rotation, so it's not A. B, Jupiter is less dense and has a shorter period of rotation. It does sound like it. Less dense and has a shorter period of rotation. Yeah, I will go with B. Definitely. Let's see if C and D would work. Jupiter is more dense. No, Jupiter is less dense. C is out. D, Jupiter is more dense and has a shorter period of rotation. Jupiter is not more dense, so that is definitely out as well. Our correct answer there is B. Yay! Shout out to those who got it right. Okay, so now with that, I want you to attempt question number 2. I'm going to zoom out a little bit so you see all the diagram, and also you have the question packet on the Google Classroom. Ensure you have it open in another tab so you can look at it more clearly there. Go ahead and attempt question number 2. Okay, so the question is asking which graph best represents the relative period of rotation of Mercury, Venus, Earth, and Mars. So we are looking at the terrestrial planet. These 4 planets, they are the terrestrial planets: Mercury, Venus, Earth, and Mars. And we're looking at the period of rotations of each of them. So these are the keywords there: period, relative period of rotation, and then these are the 4 planets that we are looking at. So I'm going to go back. It's still the same Earth Science reference table, page number 15. This time around, I'm looking at these 4 terrestrial planets and Mars, 4 terrestrial planets, and I'm also looking at their periods of rotation. Let me be sure. Let me go back. Yeah, period of rotation. So I'm looking at the period of rotation. So amongst these 4 planets, which one revolves the fastest? Earth. Earth rotates fastest, so Earth is number 1, is very fast. Then after Earth is Mars, that will be our number 2. Then next is rotation is Mercury. Mercury takes 59 days to complete one rotation. Slow guy. And then Venus takes 243 days to complete one rotation. Whoa, really slow. So it's Earth being the highest, the fastest, and then followed by Mars, and then lastly Venus. So let's look at that. So I have Mercury, Venus, Earth, and Mars. So period of rotation, the highest guy that has the highest period of rotation is Venus, because Venus is 243. So Venus should have the tallest bar. So Venus should have the tallest bar. Any other bar with Venus having or not being the tallest is wrong. So B is wrong because Venus is very short here. Venus is very short here, so definitely not D. Venus is very short here, definitely not C. So our correct option is A, because Venus takes 243 days. Easy breezy. Now let's continue. Question number 3. I'll let you attempt it. I'm going to zoom in. Also use your PDF packet. Give me an answer. All right, question number 3 says, which star type has a surface temperature of 400,000 Kelvin and a luminosity 1,000 times greater than the sun? So I have temperature of this and luminosity of this, and the question says than the sun. So we know what luminosity is. Luminosity is brightness, right? Yeah, brightness, how bright a star is. Okay, so what page of the Earth Science reference book can help us with this? This is definitely ESRT page number 15, characteristics of stars. So we go back again to this. All right, and the question says the star that has a temperature of 4,000. So I see my temperature meter all the way at the bottom here. So I'm looking for something that is around 4,000. So I can just use my imaginary sense that way. And then it has luminosity 100 times. And sorry, is it 100 times? 1,000 times greater than the sun. So the luminosity is this side, brightness, and 1,000 I'll draw this way. So we are looking at something around this region. All those stars that are, they are 1,000 brighter than the sun, and then 4,000 Kelvin in terms of temperature. So let's go back to our option. Let's see. A says dwarf. No, definitely not dwarf. Dwarf, they are very dim. They are all the way at the bottom here. Let me choose a different color. Dwarfs are all the way at the bottom here, so definitely it's not dwarf. Main sequence stars. No, a main sequence star cannot be 1,000 times. Only very few of the main sequence stars are as big or 1,000 times bigger than our sun. So and then it's also said it has to be 4,000. Okay, so I already circled the region there, and the answer there is giants. So it has to be C. It has to be C. It's the giant guys that falls within that range. Good. So using the same idea and the same ideology, I'm going to zoom out a little bit and let you guys attempt question number 4. All right. Question number 4. Blah, 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 blah. And then at the bottom, the main question is, which is a possible surface temperature of the star at point 2? Surface temperature, possible surface temperature at point 2. Now, since it's point 2, so we are looking at this here. What is the temperature around that area? I know my temperature scale is at the bottom of the ESRT, and of course at point 2 is just a little bit to the left of our sun. So you see the sun there. So we are looking at something around, forgive me, I have to take all this out. So I'm looking for something that just a little bit to the left of our sun. All right, and then I'm going to draw it all the way down to get an idea of what the temperature could be. So this would definitely fall somewhere around 6,000 or a little bit more than 6,000. Remember, temperature is increasing that way. So this falls within 6,000 and a little bit upward. So between 6,000 to 7,000 thereabout. So looking at my option, 7,000 definitely is the closest to that range. Not 3K. 3K is all the way in that region. So 3K is definitely too low. Definitely not 5,000 either. 5,000 definitely not. 5,000 is somewhere around here. Remember, the area is to the left of the sun. And lastly, what's the other option? 10,000. 10,000 is too all the way far. All the way is too far from the sun. The reference point is 2, very close to the sun there. So yeah, our correct answer is C for question number 4. All right, let's move on. Question number 5. I want you to attempt it. So question number 5 says, during which geologic period did plants and animals first appear in land environment? During which geologic period? So that gives me an idea where I should be looking at in the Earth Science reference table. It has to be page 8 and 9 because that is the page that talks about geologic history. Did plants and animals, so this thing has life. Plants and animals are things that once have life. So definitely I should have my eyes on the part that says, I'm going to use this instead. I'm going to have my eyes on life on Earth. Okay. Because the things that the question is talking about are things that have life. So I'm looking at life on Earth. If it was a geologic event, such as mountain building or continental drift or the position of continents or the position of one thing or the other, those are geologic events and you're looking at those columns. All right. But when it comes to life, something that once had life, then you're looking at this column. If you're talking about something that has to do with fossils and when a particular fossil existed, then you're definitely looking at that column as well. So it's important that you get that idea. If once anything has life, you're looking at the first two, and once anything does not have life, like mountain building and sand and deposition and continental drift and stuff like that, you're looking at the last two. All right, let's take all that out. Let's go back to the question. Did plant and animal first appeared, emphasis on first, in the land environment? All right, so I already said this is going to be ESRT, page 8 and 9. All right, this is how you should annotate in your midterm. We expect you to annotate. Remember, you gain points for your annotations. All right, if you don't annotate, how exactly are you going to pass? Your annotation is worth almost half the mark. So put that at the back of your mind. Annotate, 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 annotate. You have enough time. You're going to have enough time in the midterm to do all your annotation. Good. All right. So we're talking about land animals and when they first appeared. So I'm going to zoom in to the life on Earth version here. And I'm looking for something that says something about animal or land animals appearing. First coral reef here, vertebrate dominant, abundant, all these are still here. Right here we have it. Let me erase that. Control Z, Control Z. So I see this here. Earliest. Bro, give me my marker. What's wrong with you?
Give it a big. There you go.
All right. Earliest land and animals right here, and the period is the Silurian period.